Food packaging is everywhere, in every grab and go meal and every takeout order we enjoy. But what happens to all that packaging when we're done with it? Shockingly, food packaging makes up about 40%, nearly half, of the world's plastic waste. It takes hundreds of years to decompose, releasing harmful chemicals into the environment along the way. That's why our choice of packaging material is so important. Thankfully, change is on the horizon. Here in California, new policies are requiring all packaging to be recyclable or compostable by 2032. Globally, this aligns with the UN Sustainable Development Goals, which emphasize responsible consumption and production. These initiatives are pushing industries to rethink the materials they use. In this video, we'll explore some of the most promising materials for sustainable food packaging: rPET, chipboard, PLA, and mushrooms. We'll also explain why rPET stands out as the best option.
Let's start by introducing the contenders. First, we have recycled polyethylene, commonly known as rPET. It's made from recycled plastic that can be converted into new packaging. It's durable, lightweight, and can be recycled repeatedly, reducing the need for manufacturing new plastic. Our second option is chipboard, made from recycled compressed fibers. It's sturdy and already widely used in the packaging market for dry goods like cereal. Next is polylactic acid, or PLA. PLA is a bioplastic made from renewable resources like cornstarch or sugarcane. It's compostable under industrial conditions and offers a biodegradable alternative to traditional plastics. Finally, we have mushroom packaging, an innovative material grown from agricultural waste and mycelium, commonly known as the root structure of mushrooms. It's fully biodegradable and can decompose naturally in as little as 20 days.
When evaluating these materials, we compared them based on three key pillars: economic impact, environmental sustainability, and social implications. In our analysis, rPET consistently performed well across all categories. It may not have been the best or worst in any single area, but its affordability, wide availability, and low carbon footprint make it the most balanced and practical choice for sustainable food packaging. Chipboard is a strong contender due to its cost efficiency and widespread use. However, its high water and energy consumption during production push it down to second place. While PLA and mushroom packaging are exciting and innovative alternatives, they remain immature technologies. Their production processes require significant energy, and these technologies aren't yet optimized, leaving gaps in both their economic and environmental performance.
So what's next? To move closer to achieving meaningful change, we need to expand rPET production to cover more of the U.S. food packaging market. But how do we do this in the current market environment? The manufacturing capacity is available, but the problem arises from not having enough raw material input into the process. This is not because we don't have enough of the raw materials, but because our recycling rate is low in the U.S. The current rate of recycling in the U.S. is about 30%, compared to about 50% in Europe. If you've ever been to Europe, you'll see different waste bins for different types of materials that get picked up on different days. While this may take a little time to get used to, we must improve our recycling programs and educate consumers on proper recycling methods. At the same time, we must continue to innovate and optimize other sustainable materials like PLA, chipboard, and mushroom packaging. Change starts with simple actions, like supporting companies that use sustainable packaging materials. Together, we can create a future where food packaging protects both the food we put in our bodies and the planet we call home.